Hello everyone, welcome back to my YouTube channel. I, Mr. Yogesh, Faculty of Mathematics, and I am here to put excitement back into the education. In this lecture, we are going to discuss question number 2A as an activity based question and question number 2B as a solving from chapter Trigonometry. All questions are from question bank provided by Maharashtra State Board. Look at the first question. Prove that cos square of theta into 1 plus tan square of theta that is equals to 1. Complete the activity given below. We have now LHS is of the form cos square of theta into 1 plus tan square of theta. Now as per the trigonometric identity, we well known 1 plus tan square of theta that to be equals to we are having is sec square of theta. So that we are getting cos square of theta into 1 plus tan square of theta. Now we have sec square of theta. Now once we are taking the square of cosine and the second trigonometric ratio as a common, so that we are getting cos of theta into sec of theta the whole square. Then next to it, once we well known sec theta be the reciprocal of cos theta, that means we can write sec theta to be equals to 1 upon cos theta. So once we replace sec of theta by its value, we are getting cos of theta into 1 upon cos of theta the whole square. Now cos theta from numerator denominator getting cancelled, we might remain with the 1 and the whole square as it is. Now 1 square is equals to we have a 1 and that is equals to our RHS. Now look at the second activity. We have it is of the form 5 divided by sin square of theta minus 5 times cot square of theta. Complete the given activity. Look at here, we have 5 divided by sin square of theta minus 5 times cot square of theta be the trigonometric expression we have given here. So once we take 5 common from those two terms, so that we are getting 5 times in bracket 1 upon sin square of theta minus of cot square of theta. Now we well known reciprocal of sin theta is the cosec theta, so that once there is a square, so that 1 upon sin square of theta we can write it is of the form cosec square of theta, so that we are getting 5 times now in case of bracket cosec square of theta minus cot square of theta. We have the trigonometric identity 1 plus cot square of theta that is equals to cosec square of theta. Once we shift cot square of theta from LHS to RHS, so that we are getting 1 to be equals to now cosec square of theta minus cot square of theta. Hence we can replace now cosec square of theta minus cot square of theta by their value as a 1 and 5 into 1 we are getting a 5. So that we may have now the value of 5 divided by sin square of theta minus 5 times cot square of theta that to be equals to a 5. Now look at the next activity. We have it is of the form if sec theta plus tan theta equals to root 3, complete the activity to find the value of sec theta minus tan of theta. Now we have fundamental trigonometric identity is of the form sec square of theta to be equals to we have 1 plus tan square of theta, so that sec square of theta minus of once we shift tan square of theta from RHS to LHS, so plus tan square of theta will become say minus tan square of theta. So sec square of theta minus tan square of theta that is equals to we have a 1. Now we well known we have the factors for a square minus b square that to be equals to a plus b into a minus of b, where here a value is nothing but the sec theta and b value is nothing but the tan theta. So that we are getting sec theta plus tan theta into sec theta minus tan theta be the factors for sec square of theta minus tan square of theta, and that is equals to we have a 1. Now we have the value of sec theta plus tan theta that is equals to a root 3. So try to replace this sec theta plus tan theta by its value as a root 3, so that we are having now root 3 into sec theta minus tan theta equals to 1. Once we shift now root 3 from LHS to RHS, multiply root 3 becomes divisor to whom? To RHS, that is 1. So the value of sec theta minus tan theta is equals to we have 1 upon root 3. Look at the next and last activity, activity number 4. We have if tan theta to be equals to 9 divided by 40, complete the activity to find the value of sec theta. Now as per the fundamental trigonometric identity, we have sec square of theta equals to 1 plus tan square of theta. Now once we have given tan theta value is 9 by 40, squaring on both sides the tan square of theta value, we have 9 divided by 40 the whole square. So the sec square of theta is equals to 1 plus. Now once we separate out the square of numerator and denominator, we are getting 9 square is 81, while 40 square we have 1600. Once we will do the cross multiplication, so that we are getting 1600 plus 81 divided by 1600. 1600 plus 81 we have 1681 divided by we have 1600. This is the value of sec square of theta. Now we have to write the value of sec theta. So once we take square root on both sides, we are getting sec square of theta as a square root sec of theta, while that is equals to square root of, we are having 1681 divided by 1600. Once we separate the square root of numerator and denominator, square root of 1681 we have 41, while square root of 1600 we have a 40. So the value of sec theta we are getting 41 divided by a 40. Hence we have our fourth activity. Look at the first question now from question 2b. Solve the following questions, 2 marks each question. Within it, first sub question we have, if cos theta equals to 24 divided by 25, then sin theta is equals to. So now once we have given here value of cos of theta, that to be 24 divided by we have 25, and we have to evaluate the value of sin theta. So look at the relation between the trigonometric ratio sin theta and cos theta. As per the fundamental trigonometric identity, we have here cos square of theta plus sin square of theta, that to be equals to a1. Now we have given the value of cos theta is 24 by 25, so that cos square of theta becomes 24 divided by 25 the whole square, and plus sin square of theta remains as it is, that is equals to we have a 1. Now once we separate out the square of numerator and denominator, 24 square we have 576, while 25 square we have 625, plus sin square of theta remains as it is, that is equals to a 1. Now to evaluate the sin theta, first of all let us try to evaluate the value of sin square of theta. So for that, try to shift 576 divided by 625 from LHS to RHS. So plus value becomes now the minus, that means we are getting 1 minus 576 divided by 625. Do the cross multiplication over RHS, we are getting 625 minus 576 divided by 625. So after all simplifying, we are getting the value of sin square of theta is equals to 625 minus 576, we are getting 49 divided by 625 as it is. Now to evaluate the value of sin theta, taking square root on both sides to cancel out the squares from LHS, so that square root of sin square of theta we have the sin theta, while that is equals to, we are getting 49 divided by 625 is a square root. So that once we separate out the square root of numerator and denominator, we are getting value of sin theta to be equals to square root of 49 is 7, square root of 625 is 25. So the value of sin theta we have 7 divided by 25. Now look at the second sub question. We have prove that sin square of theta divided by cos theta plus cos theta is equals to sec theta. So for that, let us try to consider the LHS. LHS is of the form we are having sin square of theta divided by cos of theta plus we are having cos of theta. So let us try to do the cross multiplication. We are getting sin square of theta plus cos theta into cos theta is cos square of theta whole divided by we have cos of theta. Now as per the fundamental trigonometric identity, we have the value of sin square of theta plus cos square of theta, that to be equals to a 1. So that after all simplifying the LHS, we are getting sin square of theta plus cos square of theta is 1 divided by cos theta. Now reciprocal of cos theta means 1 upon cos of theta, that is equals to we have sec theta, and which is exactly equals to our RHS as a sec theta. So that at the end we are writing the statement, we have sin square of theta divided by cos of theta plus cos of theta, that to be equals to sec of theta. Hence we have our proof. Look at the third sub question, which is of the form prove that 1 upon cosec theta minus cot theta is equals to cosec theta plus cot theta. Try to consider your LHS. LHS is of the form 1 upon, we are having cosec of theta minus cot of theta. Let us try to now rationalize the LHS. That means we have to multiply and divide simultaneously to the given rational by the conjugate of denominator. Which is your conjugate of denominator? We have to change the middle sign only for cosec theta minus cot theta. We have the conjugate of it, cosec theta plus cot theta. So try to multiply by cosec theta plus cot of theta, and simultaneously we have to divide by cosec theta plus cot theta. Look at the denominator. Denominator is of the form a minus b into a plus b. Those are the factors of a square minus of b square. So that after all simplifying the LHS, we are getting 1 into cosec theta plus cot theta is cosec theta plus cot theta, and whole divided by we are having cosec theta minus cot theta into cosec theta plus cot theta. We are getting cosec square of theta minus cot square of theta. Now we have the trigonometric identity, that is 1 plus cot square of theta, that to be equals to we are having cosec square of theta. Now here once we shift cot square of theta from LHS to RHS, we are getting 1 to be equals to now cosec square of theta minus cot square of theta. So that let us try to replace cosec square of theta minus cot square of theta by its value. As per the identity, we are having it as a 1, and anything divided by 1 we have the same thing. That means after all simplifying the LHS, we are getting cosec of theta plus cot of theta, and that is exactly equals to our RHS of the given to prove statement. Hence we are writing at the last, we are having 1 upon cosec of theta minus cot of theta, that to be equals to we are having cosec of theta plus cot of theta. Hence we have our proof here. Look at the fourth sub question. It is of the form if cos of 45 degree plus x is equals to sin of 30 degree, then x is equal to. So that we have given the trigonometric equation is of the form cos of 45 degree plus x, that is equals to sin of 30 degree. Now once there is a cosine ratio in case of the LHS, so try to convert that RHS in terms of the cosine ratio. That means we are converting here sine ratio in terms of the cosine. So as per the complementary angle formula, we well known, cos of 90 minus theta becomes the sin theta, where here theta value we have 30 degree. So that we are getting cos of 45 degree plus x, that to be equals to we are having sin of 30 degree as now in terms of the cosine ratio cos of 90 minus 30. So that cos from both side getting cancelled, we are getting 45 degree plus x, that to be equals to 90 degree minus of 30 degree. Now 90 degree minus of 30 degree we are getting degree. Now to evaluate the value of x, try to shift 45 degree from LHS to RHS. Positive 45 degree becomes negative 45 degree. So that we are getting the value of x is 60 degree minus 45 degree. We are having x to be equals to 1515 degree. Hence we have to evaluate here value of x, which is equals to we have 15 degree. Now look at the fifth question. It is of the form if tan theta plus cot theta equals to 2, then tan square of theta plus cot square of theta is equals to. Now here we have given the value of tan theta plus cot of theta, that to be equals to 2, and we have to evaluate the value for tan square of theta plus cot square of theta. Now we well known a square plus b square, we can write it is of the form a plus b the whole square minus 2 times ab. So that here once we consider the value of A is tan theta and B is cot theta, so that we can write tan square of theta plus cot square of theta, it is of the form tan of theta plus cot of theta the whole square minus 2 times tan of theta into cot of theta. So that to be equals to, now we have the value of tan theta plus cot theta is 2. So that we are getting 2 square minus of 2 into tan of theta into, we can write now the cot theta be the reciprocal of tan theta, means cot of theta to be equals to, we are having now 1 upon tan theta. So that tan theta from numerator denominator getting cancelled, we are getting the value of tan square of theta plus cot square of theta to be equals to 2 square is 4 and minus of 2 into 1 we have a 2, 4 minus 2 is 2. So the value of tan square of theta plus cot square of theta, that is equals to, we have a 2. Look at the question number 6 now. We have to prove that sec square of theta plus cosec square of theta equals to sec square of theta into cosec square of theta. So for that, let us try to consider the LHS. LHS is of the form, we are having sec square of theta plus cosec square of theta. Now we well known, we can write sec of theta as a reciprocal of cos theta, means 1 upon cos theta, and cosec of theta as the reciprocal of sin theta, means we are having 1 upon sin theta. So after all simplifying the LHS, now we are having there is a square. So sec square of theta becomes, now we are having 1 upon cos square of theta, and cosec square of theta we are having now 1 upon sin square of theta. Once we make the cross multiplication, so that we are getting the simplified form of LHS is of the form sin square of theta plus cos square of theta whole divided by, we are having cos square of theta into sin square of theta. Now as per the trigonometric identity, first sin square of theta plus cos square of theta is equals to 1. So after all simplifying the LHS, we have 1 upon cos square of theta into sin square of theta. So the given ratio we can write it is of the form 1 upon cos square of theta into 1 upon sin square of theta. Now again the same thing, reciprocal of cos of theta is equals to, we have sec theta, reciprocal of sin of theta is equals to, we have cosec theta. Once there are the square, so reciprocal of cos square of theta we are having sec square of theta into reciprocal of sin square of theta we are having cosec square of theta, and that is exactly equals to now the RHS. So that at the end we are writing sec square of theta plus cosec square of theta, that to be equals to, we are having sec square of theta into cosec square of theta. Hence we have our proof here. So at the end we are writing hence proof. Look at the 7th sub question from question 2b. Prove that cot square of theta into sec square of theta is equals to cot square of theta plus 1. Now once here we consider the RHS. RHS is of the form cot square of theta plus 1. Cot square of theta is nothing but the reciprocal of tan square of theta, and plus 1 remains as it is. Now once we are making the cross multiplication, we are getting 1 plus tan square of theta whole divided by, we have tan square of theta. Now as per the trigonometric identity, 1 plus tan square of theta is nothing but sec square of theta, and whole divided by, we have tan square of theta. So that now we can write the given ratio as a sec square of theta into 1 upon tan square of theta. Resubstitute the value of reciprocal of tan square of theta as a cot square of theta. We are getting the simplified form of RHS is of the form sec square of theta into reciprocal of tan square of theta becomes cot square of theta. Multiplication is always commutative, so that we can write sec square of theta into cot square of theta as a cot square of theta into sec square of theta. So after all simplifying the RHS, we are getting exactly LHS. Hence LHS equals to RHS. So at the end we are writing, we are getting cot square of theta into sec square of theta, that to be equals to cot square of theta plus 1, and hence here we have our proof. Look at now the 8th sub question from question 2b. If 3 times sin theta equals to 4 times cos theta, then sec theta is equals to. We have given here 3 times sin theta is same as that of 4 times cos of theta. Now once we shift cos theta from RHS to LHS and 3 from LHS to RHS, so that we are getting sin of theta divided by cos of theta, that to be equals to 4 by 3. Now sin theta upon cos theta is equals to tan theta, so that we are having at start the tan theta value is equals to 4 divided by 3. Now as per the fundamental identities in trigonometry, we are having sec square of theta, that to be equals to 1 plus tan square of theta. Now the value of tan of theta we have 4 by 3. Once we are having here tan square of theta, so tan square of theta value we have 4 by 3, the whole square here. Now once we separate out the square of numerator and denominator, 4 square is 16, 3 square is 9. Let's do the cross multiplication over here. We are getting 9 plus 16 divided by 9. Now the value of 9 plus 16, that is 25, divided by 9, that is equals to, we have sec square of theta. Here we have to evaluate the single value of sec theta. So to cancel out the square from LHS, take square root on both sides. We are getting square root of sec square of theta is the sec theta, and that is equals to, now we are having square root of 25 divided by 9. So that sec of theta equals to, once we separate out the square root of numerator and denominator, square root of 25 is 5, square root of 9 is 3. So the value of sec theta we are having 5 divided by 3. Look at the question number 9. If sin of 3a is equals to cos of 6a, then angle A is equals to. So that here we have given sin of 3a is equals to cos of 6a. Now once there is a sin ratio in case of the LHS, so try to convert that RHS in terms of the sin ratio. We well known as per the complementary angle formulae from trigonometry, we can write sin of 90 minus theta is cos theta. Here theta value we have 6a. So that we can able to write now sin of 3a, that is equals to, we are converting cosine ratio in terms of the sin ratio here. So that we are getting sin of 90 minus theta value we have 6a. Now sin from both sides getting cancelled. We are getting 3a to be equals to 90 minus 6a. Now once we are shifting minus 6a from RHS to LHS, minus 6a becomes now the plus 6a. 3a plus 6a, that is equals to, we are having 90. Now 3a plus 6a becomes the 9a. 9a is equals to 90. Once we divide both sides by 9, 9 tens are, we have a 90. So the value of a is equals to, we have a 10 here. Now look at the 10th sub question from question 2b. We have to prove that sec square of theta minus cos square of theta equals to tan square of theta plus sin square of theta. So let us try to consider the LHS of given equation. We are having sec square of theta minus cos square of theta. So at start we can't require the sec square of theta. So that try to convert sec square of theta as per the identity. We well known sec square of theta to be equals to 1 plus tan square of theta. So after all simplifying the LHS, we are getting sec square of theta becomes 1 plus tan square of theta and minus of cos square of theta remains as it is. Now we can write the LHS is of the form 1 plus tan square of theta is same as that of tan square of theta plus 1 and minus of cos square of theta as it is. Now as per the trigonometric identity, we have cos square of theta plus sin square of theta, that is equals to 1. Once we shift the cos square of theta from LHS to RHS, So sin square of theta value we have 1 minus cos square of theta. So from now LHS 1 minus cos square of theta we can replace by its value. As per the identity we are getting sin square of theta. So that after all simplifying the LHS we have tan square of theta plus sin square of theta, which is same as that of the RHS. So hence here LHS to be equals to we have RHS. LHS is of the form we have sec square of theta minus of cos square of theta, and that to be equals to the RHS is of the form now tan square of theta plus sin square of theta. Hence we have our proof here. Now look at the question number 11. We have to prove that tan A divided by cot of A is equals to sec square of A divided by cosec square of A. So let us try to consider at start the LHS is of the form tan A divided by we are having cot of A. Now we well known tan of A we can write now the sin of A divided by cos of A, while cot of A we can write it is of the form cos of A divided by sin of A. Now once we shift the denominator from denominator to numerator, so whose reciprocal will be the multiplier to numerator. That means we are having simplified LHS now is of the form sin A upon cos A into we are getting sin A upon cos A. Now here sin A into sin A becomes sin square of A and divided by cos A into cos A becomes cos square of A. So after all simplifying the LHS we are getting sin square of A divided by cos square of A, and that is nothing but we are having tan square of A. Once sin A upon cos A is the tan A, there is a square, we are getting tan square of A. Now let us try to simplify furthermore the RHS, which is of the form we are having sec square of A divided by cosec square of A here. Now we well known sec of A be the reciprocal of cos of A, while cosec of A be the reciprocal of sin of A. So that we can write now the RHS is of the form sec square of A becomes now, once we are making squaring on both sides, sec square of A is equals to we have 1 upon cos square of A, and once we are making square on both sides here, so that cosec square of A we can write 1 upon sin square of A. The same thing, once we are shifting denominator from denominator to numerator, whose reciprocal becomes now the multiplier to numerator, we have, that means 1 upon cos square of A into sin square of A divided by 1. Once we simplify the RHS, we are getting 1 into sin square of A becomes a sin square of A, and 1 into cos square of A becomes cos square of A. So after all simplifying the RHS, sin square A upon cos square of A becomes tan square of A. Now look at the simplified form of LHS and RHS, both are identical, same, that is tan square of A. So that we can say here LHS to be equals to we have the RHS. So at the end we are writing tan of A divided by cot of A to be equals to we are having sec square of A divided by cosec square of A. Hence we are having our proof here. Look at the question number 12 from second B question. Prove that sin theta plus tan theta divided by cos theta is equals to tan theta into in bracket 1 plus sec theta. So try to consider again the LHS, which is of the form sin of theta plus we have tan of theta whole divided by cos of theta. Now once we separate the denominator, we are getting sin theta upon cos of theta plus tan of theta divided by cos of theta. Now we well known sin theta upon cos theta is the tan theta, and tan theta divided by cos of theta we can write it is of the form tan theta into 1 upon cos of theta. Now reciprocal of cos of theta we have a sec of theta, that means we can write now tan theta plus we are having tan of theta into 1 upon cos of theta is the sec theta. Now we can able to take tan theta common here. So LHS is of the form tan of theta into 1 plus we are having sec of theta, and which is exactly equals to our RHS. So hence we are writing LHS to be equals to RHS. LHS is of the form sin of theta plus tan of theta whole divided by cos of theta, that to be equals to, now we are having tan of theta into in bracket 1 plus sec of theta. Hence we have our proof here. Look at the question number 13 from question 2b. Prove that cos square of theta divided by sin theta plus sin theta is equal to cosec of theta. Try to consider the LHS. LHS is of the form we are having cos square of theta divided by sin theta plus we have sin theta. Once we are making a cross multiplication, so that we are getting cos square of theta plus sin theta into sin theta, we are having sin square of theta whole divided by we have here sin of theta. As per the trigonometric identity, cos square of theta plus sin square of theta is equals to, we have a 1. So 1 upon we are getting sin theta. And reciprocal of sin of theta we have cosec of theta. So once we simplify the LHS, we are getting cosec of theta, and that is exactly equals to the RHS. Hence we have our proof here, that is cos square of theta divided by sin of theta plus sin of theta, that to be equals to, we are having cosec of theta. Hence we are writing our proof here. Look at the question number 14 from question 2b. We have proved that cos theta divided by 1 plus sin theta is equals to 1 minus sin theta divided by cos theta. So try to consider the LHS, which is of the form cos theta divided by 1 plus sin theta. Now once we are making rationalization of denominator, that means for a given rational we have to multiply and divide simultaneously by the conjugate of our denominator. Denominator is of the form 1 plus sin theta, whose conjugate we are having 1 minus sin of theta. So try to multiply and divide by 1 minus sin of theta here. So that after all simplifying the LHS, we are having now cos theta into 1 minus sin theta, we are getting cos theta into in bracket 1 minus sin of theta whole divided by, look at the denominator, which is of the form a plus b into a minus b. Those are the factors of a square minus b square, where value of a is 1, so that we are getting 1 square, minus of value of b we have sin theta, so sin of theta the whole square means we are writing sin square of theta. 1 square we have a 1, so that after all simplifying the LHS, which is of the form cos theta into 1 minus sin theta divided by 1 minus sin square of theta. We have the trigonometric identity, that is cos square of theta plus sin square of theta, that is equals to 1. Once we are shifting sin square of theta from LHS to RHS, we are getting cos square of theta to be equals to now 1 minus sin square of theta. So 1 minus sin square of theta from denominator we can replace by its value as a cos square of theta. So that we are getting now the LHS is of the form cos of theta into 1 minus sin theta divided by, we are having cos square of theta. So 1 cos theta from numerator denominator getting cancelled, so that we are having LHS to be equals to now 1 minus sin of theta divided by cos of theta, and that is exactly same as that of our RHS. So hence LHS equals to RHS. LHS is of the form cos theta divided by 1 plus sin theta, and that to be equals to, we are getting after all simplifying 1 minus sin theta divided by cos of theta. Hence here we have our proof. So that here we discussed the question number 2a and 2b from question bank provided by Maharashtra State Board. So today we will stop here. During the next lecture we are going to discuss question 3a and 3b from the same chapter, that is Trigonometry. Thank you.